Good morning, students. Today discuss about the computer graphics 2D transformations. We already know that what is the 2D object. 2D object simply can draw with some object. You can able to refer it as the one triangle here. The triangle can able to write this is 2D object. We have that is the x and y coordinate only available. Okay, suppose consider by this x and we consider by this having the y coordinate. So this having the x and y coordinate, you can able to see by the only the front view only be able to see. This is a point referred by the point. This point may be referred by the one particular this is a point. This is also having the another point. Okay, we are able to refer by here as the another point. Like here having one points now. Similarly having the another point. Okay, here having the another points are there. 3 point we have to be connect. Okay, connect we have to write by the we have to write. Okay, we have to write by the one object able to plot. Here 1 point to first point P1 to P2, then P2 to P3, P3 to P4. So we can see here as the point P1, the point having the P1, this is having the P2, this compromise the P3. Okay, in this point, you can able to refer as the what is the extra points are. Each and every point you have in the x comma y. Likewise, coordinates are there. Based on the coordinate, able to plot. Example: if you want to consider by some objects are there, object you can plot here. Suppose in this example also we consider by the some points. Some points how to draw by 2D objects for here. Suppose here consider by this is having that is the one. This is having the two. 1, 2, 3, 4, 5, 6. Okay. This also compromises the 2, and then 4, 6, and 8. This may be 10. Consider by this is my point. So our points having that is the first point. Okay, here having the 4 comma 10. Okay, this is having the 4 comma 10. This compromise the 2 comma 2, and this compromise 6 comma 2. These are the points are we have 6 comma point. 3 point will give. We give to give the first point as the 4 comma 10. The second point go to the 2 comma 2. I go to 6 comma 2 will be given. The plot again. We want to give the 3 commands need to be given. First point having the 4 comma 10. Okay. After having the 2 comma 2, then visiting the point. Next having 6 comma 2. Again revisit having the 4 comma 10. So automatically complete in that all the point need to be plotted. Is considered by the 2D object. Okay. This having there is the 2D object. Okay, this is called about the 2D object, how to plot the points. Okay, here I have an example about 2D object. What are content need to be can able to see here. Why transformations are required? Okay, what is transformation? Why transformation is required? The transformation happening is the translation, scaling, rotations are there, homogeneous coordinates are there, matrix multiplication, and combined transformations are there. Okay, when I go by the transformation, we have some object described. Transformation used to move from as the object from as a scale. Here, having is the 2D objects are given. Actually, given by the 2D object only given by here. Okay, in this one, 2D object, you have to see by the 3D viewing angles are given here. Okay, but you have to see by the operation. Operation is the two objects are able to perform this task further. One is the translation want to perform, another one to go from as scaling it, rotation need to perform. Okay. Here having the translation means move from the object from one place to another place. From here is their object. This object will come here. Before here and after here. They want to be move the object from here to here. This object may be rotate from here, rotate down into that. Likewise, having that something happened. Here having the result. This is consider first object. This have to come from the translation transformation done. After transformation perform the rotation need to perform. After rotation again perform with the having the transformation need to perform here. So we can able to see here this is having the original object. Original objects are there. You can able to move from here. Move from here to here, here to there. You can able to move it. After the moving, perform with rotation to perform. After rotation to perform, again there's some operations are there. This object will be moved now. You can want to be a move from as a translation translator will perform from here to there. Okay, this is having that some example. Okay, here what is the translation be updated here? The translation having there is a object on the reposition along with the straight line path from the one coordinate to the another coordinate. The translations are there now. Translate. The translate we always saying the translate. The T is there. T. Or how many coordinates we have in the two coordinates are the x comma y. So call about the t of x comma t of y. The original coordinate represented by the xy. We have to represent by the moving point. New position represented by the x dash and y dash along with having the t. So we can write by the p dash equal to p plus t. Okay, the p plus t, the p already having the x comma y are there. So write by the x dash equal to x plus t of x and y dash equal to y plus t of y. They have to apply by here as it is the addition need to be applied here. Addition. So given the some example for that example, we have translating pairs are the TFX, TFI call about the translation vector, something called shift vectors are there. This is my original points are there. This is the original point. This is a moving distance translation given. It's from a new points are the new points. Okay. Yeah, what is the formula for that? First of all, convert into this the two-dimensional translation into the matrix format. The two-dimensional is there. You want converting by the matrix format. We noticing by the x comma y you have to give it. Points having x comma y, new point having the x dash comma y dash, t having this t of x comma t of y. If you want to plot one point, the point having some triangles are there, triangles, some objects are there, these many objects are there. You want to move from a house, you want to shift from one location to another location. It's considered by the original position. This comes from by translating the position, translating distances. This is having the moving objects. Considered by this is a translation. Next, comes from scaling. Scaling is the altered size of an object. Okay. This operation can be carried out for the polygon for multiplying the coordinate value s comma y. Each vertex of the scaling factor having the s of x and x of y produce the transform coordinate having the x dash comma y dash. Look like as the same, but here the using by the scaling pattern is by the s of x and the s of y. Previously, it was translation having the t of s t of y. They use from as the addition symbol want to be applied on the transformation translation. Here they want to apply by multiplication. Okay, multiplication want to apply. The both formula will be same as this from as the coordinate are going to change x dash into x multiplication into s of y multiplied into the y of x. Here, what are coordinates are there? Here, having the transformation coordinate, you have to apply by the matrix format. X dash and y dash compromise s of x and s of y. Okay, here having the x and y. We write from as the alternative from as the equation as the p dash equal to s into p. Okay, here we use by the scaling factor given by the matrix formats are given matrix format. Okay. Okay, what is the matrix format is there? Suppose here having the is the tuning by the square. Okay, we have to apply by the s of s equal to 2, s of y equal to 1. So here you want to increase by the s of s equal to 2. So automatically this from as the x factor now, then just make it by double. But y value given s of y given by 1. So it will not possible to increase. So this is the original object size. They can expand it into the scaling factor going to be updated here. Suppose if you are given the value is having that is a 2 also here. So automatically this object may give a double size, so it can able to cover on like this much able to come when having the is s of y equal to 2. Okay. Next one, you can see the what are the parameters are there. Today having the is the scaling factor having the s of x and s of y. It assumes the value is less than 1. Okay, object must be as though closer to the coordinate value. Okay, if it is greater than values are there, so further code size is going to be increased. Less than ones are there, it is going to be shrink on the object. Shrink on the object can able to refer here. So suppose this my original points are there. If you agree the s of x and s of y having the result 0.5. 0.5 are there. The scaling factor want to be applied. Suppose we consider by here. Suppose we have the coordinate. Here has the 2 comma 2. Example. Here having the 5 comma 6 comma 6. Here having that is the 6 comma 6 is there. Okay. When you want to apply the formula 0.25, 0.25 are there. What happened 2.5? 2 into 0.25 become as a 1. 0 into 2.5 equal to become as a 1. Here 0.1 want to be applied here. Okay. Here want to be applied by 0.5. You got by 3. Okay. Here you got by the 3. So automatically 3 by 3 is are there. This value, the 0.5 are there both side. Automatically the object is going to be shrink to this level. So what is our coordinate? 1 comma 1 to 3 comma 3. Previously having that is the 2 comma 2 to 6 comma 6 is the big objects are there. Now going to be decreasing that one. So reducing size of the object when applied by the s of x and s of y equal to 0.5. This having that is the scaling factor. Okay, scaling parameter. I said that one. Here having the should not give a negative value for that. That is the important point here. Negative value should not give here. Always have a scaling factor give by the 0.1 or having the 1. Okay. Next compromise that scaling chosen by the object called by fixed points are they remain as an unchanged one. The having fixed points are they fixed point we are seeing by only points now. You can able to see on with having there is a some three objects are they. Objects are they the frames. In the having the fixed point coordinates are they P1, P2, P3 are they considered by as a point. The point represent them. If you want to move the particular point, okay, if you have to move from scaling on to perform, we have to apply the formula for that. Here having there is a scaling sudden. How is scaling sudden? With respect with the new value. With the new value. Yes, we continue students. We have in the scalings are there. Next compromise the rotations are the rotation. We have in the rotation, two times rotations is going to be applied. We have in the repositioning the along the object by XY planes are there. Generating rotation, we have specified by rotation angles are given as theta, and we have the position call about the R. We are given by the scaling pattern. S of x and S of y, T of x, T of y. Here having given by the rotations be given as R. So XR comma YR. The XR confirm as the rotation points are there with having the pivot elements are the pivot element. Example for that, we have that is some objects are this having some object. Okay, we are rotating the 40 degree angles are there. Okay, angle wise, this object going to reflect. So can able to show here as the rotation angles are given by the XY plan. Suppose similar kind of things, they are going for apply with rotation for the point also. The point is there when I give the x dash comma y, we have to apply some angles are given. How much angle was given? This from originally this much angle is there. From the angle you want to shift from a some other angle, you want to modify with rotation angle. The object going to be modified. The B position will be done. But point may not possible to give the exact answer for that. Okay, we go from as that is the some 2D object. Can maybe get the correct answer for that. Here we have to give by there is the R having the constant value. Okay, we have theta having the original angle values are there. Theta having is the angle value. The formula is simple: cos theta minus sin theta minus cos theta. This is having the formula for the rotation. Okay, usually referred by the cos theta minus sin theta minus cos theta. So automatically when here is the cos theta minus sin theta will be going to be applied. Okay, we get from as the final formula is that after substituting by the rotation angle, he confirm as x equal to r cos pi and also sin pi is there. Substituting by with having this previous two equations, we got final equation equal to x dash equal to x into cos theta minus sin theta. Please remember that cos theta minus sin theta plus cos theta. In between give by the x comma y. That's it. You have to remember the angle for that. Depending upon the angle, you got substitute the value. This we got some answer. Then these x value, original values are there. Now to multiply, we can repositioning the data for that. Repositioning the data for that. I'll show you some example also how it's going on. Here, this is having there is an angle. How the formula, say matrix equations are there. The theta is equal to r into p. R having the rotation angle. Okay, when I write by the rotation matrix from here is the cos theta minus sin theta minus sin theta minus cos theta. Okay, for this the value. Okay, here having there is a rotation to perform here. We have to apply by the coordinate values are the coordinate value. We have got by the new position now. So here referred by the is the x minus r. When I go for the x dash, you go for as the xr minus and the x plus x minus r cos theta want to be applied. So in this one, finally I derive that one as in the formula is the rotation formula. The rotation compromise the angle wise want to rotate it here. The having that is a sometimes government is the clockwise also applied and also and the anti-clockwise also applied. Here give by this is the original object and I give by theta value. Pi by 6 times want to be as increase. The called that is the that rotation. We'll see some other example also. Okay, here some 2D object going to be insert here. You can insert by some object. Suppose like we insert by 2D objects. Okay, okay, we insert the object. Now you can see here. I want to rotate the angle. You see here, this is a rotating angle. This is called about the rotating angle. Once the rotating angle was done, you can able to see the object by like, okay. When I want to move from as translation, this is my original object. I want to move from the object from as the original coordinate from here. So automatically, I can able to shift here. This is considered by the translation. If you want to apply by rotation, want to perform, you can maybe rotate from some other angle, 45-degree angle want to rotate it. Okay. This is covered by rotation. After translation, rotation want to perform, we can able to move from one more to translation also. Then combine all the steps, you can able to call about as the animation want to be applied. But with this the formulas are there, when I write in the matrix value with the coordinate, the homogeneous coordinate must be required to you. Okay, without having the homogeneous coordinate value, we could not possible to move the object from as one place to another place. So we have to write from as the following matrix format. The p dash equal to m1 into p plus m2 will be there. The p1, p2 having that is the column vectors are there. M1 having the 2 by 2 matrix are there. M2 having 2 by 2 matrix are there. Okay. After having the 2 by 2 matrix are there, we having the matrix. The more convenient methods are there. Combine the multiplicative and translative terms. Having single matrix representations are there by using by the 2 by 2 matrix. 2 by 2 matrix we want to convert into 3 by 3 matrix we want to convert it. 3 by 3 matrix can able to write from as the homogeneous coordinate want to be added here. The homogeneous coordinate want to be added. You want to add in the extra point for that. The extra point is that the x comma y is there. You have to add with the x comma y with the h want to be added. H always setting it to one value. So where they having is the x value go from as x h divided by h and y go from as the y h divided by 2. Suppose having there is a general homogeneous coordinate representation can be written by the h of x into h of y into h. Okay. So having there is always h can be as a non-zero element, non-zero values. That's having the infinite between infinite number equal to the homogeneous number. Always the convenient charge we had to choose from as the h value equal to 1. So automatically having the xy1. So we have in the xy coordinate, we want to modify into the xy1. So what is that xy1 now? When I want to write that is the coordinate value. Previously what written here, when I write by here value x to y, we have to write from as the coordinate will be there. X dash and y dash go from as the x dash comma y dash is there. Now they want to modify into one more coordinate, we want to modify as a 1. So when writing the value now, here they want to adding with extra coordinate want to be written there. Extra coordinate want to be written here as a 1. Suppose you want to write the matrix format, 2 by 2 matrix are there. 2 by 2 matrix are there. We have to apply by the T of x and T of y. We'll see next slide. Okay, here what is that is the that having the after applying by the homogeneous coordinate, having the x dash and y dash, if the 1 is there, diagonal value always 1. When I write from as a translation vector, having the T of x, T of y want to be added here. With having the original coordinates are this come from as the original value. This having the translation vector with homogeneous value come from as output come from as the new point will become. Okay. Next, we are same thing right into the formula one. Formula one, you write from as the p dash equal to t in t of s comma t of y comma p. Here having the t of x, t of y come from as 3 by 3 formula want to be applied here. Similarly, we want to apply from as the rotation format. Rotation format. Previously, cos theta minus sin theta minus cos theta will be there. You can see here, this part will be always common. This part is always common for here. Okay. Only we have to see by in this portion. Okay. We have to see by in this portion. I'm simply right here. Where I draw one object, okay, object here. I can cover only this portion only. Previously having this much only. Now you want to expand to this one. When I write here now, it look like only by this object only can able to see. Remaining coordinates simply adding with one. Always without when adding by the expression with the homogeneous coordinates are required. You require by the three values are required. X, Y with the homogeneous coordinates are required. The formula is simple one. Cos theta minus sin theta minus cos theta. Always homogeneous value given by the one. Cover is the rotation. Okay, when I adding the homogeneous value, what is that having the formulas are there? Theta is equal to r theta into p. Previously you give by only r only given, now you give by theta value. But theta compromise the 3 by 3 matrix was given. Next compromise that is the scaling factor. The scaling factor, the t of x, t of y come here now. Now compromise the scaling factor, s of x and s of y compromise the diagonal value also. Diagonal value. But here having the previously, we are see by the value. You can see the three equation based very quickly. Okay, that is having the important one. When I writing by the equation, first to go from is the same formula. First to go from is the zero. Here is the first one. When I go from the translator one, we having the 110, here 0. Here having the t of x, here having t of y. The second quadrant. Remaining all position having the 0. When I apply by the rotation, here always we have in the 1, 0, 0, 0, 0. Here cos theta minus sin theta plus cos theta. That's it. Okay, the rotation scalings are remember x dash and y dash equal to 1, s of x and s of y. This compromise the addition, this compromise the multiplication. This compromise the angle wise. Okay, this is having that is a short form to remember the formula. When I apply by here as the s of x value, s of x and s of y with the scaling matrix. Having the 3 by 3 matrix. This converted into the 3 by 3 matrix. Like you can able to see by the homogeneous coordinate, you can able to give by 3 by 3 matrix. When I writing by the any formula with the example, suppose we having the points are there. When I writing the formula, t of x, t of y, we having the 1110 t of x is there now. With along with the x, y is are there. 1 into x, then having that is a 0 into y, then t of x into y. So you can multiply, you got from as the x plus t of x will be able to represent it. Like from as that is the multiplication of that is the particular value. When I give by the ABC matrix, simple normal matrix want to apply the cross multiply the value. When I apply from that is a translation one. Translation means this is a formula for the 110 t of x, t of y, x plus t of y, y plus t of y, right by here. When I apply the scaling value, having the s of x and s of y with diagonal value, multiply the s of x and the s of y. Here having the addition, here give by the multiplication for the multiplication. When I apply into this the rotation formula is that cos theta minus sin theta and having the cos theta minus sin theta with having sin theta minus cos sin theta plus cos theta will be there. Here adding with s coordinate want to be added here. It's compromise the rotation. And inverse transformation also available, not required to you. Composite transformations are there. What does composite transformation mean? We are not doing the only one task. We are perform with some tasks. Suppose translation and scaling want to perform. Other sometimes having the translation, rotating and the scaling want to perform. Like here, give by the composite transformation mean combined by the one or two operation want to be a combined. Okay, we give by that is a translation want to perform the one point. The example for that. Okay, after give by that is a translation. Here translation all the points are come from here. 2 points are there. 2 points are to be applied. 2 times we want to perform. Then I have to perform with rotation angle also perform it 2 times. So example for that I said not to example and I have to insert here for the suppose triangle only best for the triangle. This is having triangle. First, I go from as the translation. I want to perform translation. First, I have to perform with the translation. This is my original point. I move from here. Okay, we can give by the some color sets are there for us that for assumptions. We give by the fills colors. We can give by the some green color. This is having the after transformation. First transformation done. Then you have to perform with rotation. I want to perform rotation. So first to come to here, then this object going to rotate. Okay, how they want to rotate here? This is the first object. Now they perform the rotation. Rotation means with having 30-degree angle. 30-degree angle you want to rotate. So you can able to see here 30-degree angle one rotated. After transformations, okay, I'll write on by same thing. This one is the rotation for the rotation want to perform. After rotation perform with 30-degree angle and depending upon angle you given. Then you have to perform with having the scaling want to perform. The scaling means you have to increase by 0.5 percentage. 0.5 percentage means small object. That's it. If you want to apply by another scaling want to perform, you can enlarge that one. You enlarge mean double the size. Double size is going to be applied. They having double size. This having there is a scaling with having the S of x S of y equal to 2. But this compromise S of x S of y become as 0.5. This compromise the S of x and the S of y become as 0.5. Here having that is the S of x and S of y it is having that is a 0.5. This compromise the S of x S of y equal to 2. This compromise angle having 30-degree angles are there. This compromise the translating point from as the original point to here. T of x and T of y it is given by the 5 points. So this is my original object. They move from as a translation. After moving the translation, perform with rotation. After perform with rotation, I have to perform with having scaling or to perform with two different kind of scaling or to perform. These are all the operations you can call about the composite transformations are the composite transformations. Okay. Here we are writing the formula. We are given by that is the coordinate value. Theta will be given. Theta. Now compromise the transformation format. The transformation format, two coordinates are there. Now we are write from as the two successive matrix we want written there. Previously having x comma t of x of x and s of y will be there. Here we want write from as the two value need to be added. Two value means two coordinate need to be as the added one. That's the matrix value. Okay. Yeah, I said now some example for that. First of all, go for the original position was here one. When I want to move the object, first of all, need to come to this. So original position need to be come. The original position means each and every object having some center points. So center point is able to come here. Then I have to rotating the angle. Rotating the angle. After rotating the angle, again you want to be it's a written by reverse position want to perform. So first having the original points are there. The original point come to the origin will be the origin. After performing the rotation want to perform. After rotation, again return back to the same position. So color code is the general pivot points are the general pivot points. The general pivot point, what is the formulas are they? Here by the matrix formats are they? Same formula want to be applied here. Okay, same formula going to be applied from the theta value. Okay, um, then you can able to see by that there's a the scaling also. When I perform with the scaling performing, the original object come to middle and I have to apply by scaling one to perform. We have to reduce the size and I have to be repositioning that one. It's considered by the scaling one. Scaling one. Okay. And I had to perform with the other type of transformations are available. Having there is a searings are there and having that is a searings are done. Searings are done means we will not exactly say going to pull like. Suppose we can see some object. Okay, we give by the one triangle here. Okay, we'll give by the one rectangle. Okay, rectangle you can able to give. Now you have to pull from this side. So you can see now what happened. Only you can change. You can change by here. But in this one, you cannot possible to do some changes on this exactly on this. So only one angle is not possible to move it. Angle is not possible to move, but here having the searing method, you can able to pull from as a left hand side, right hand side. Suppose we have to go from as a composite transformation, we have to perform with the continuous operation want to perform. Okay. Continuous operation want to perform. That's it, students. Okay. Thank you for class. This come from method is a translation. They are having one more options are the reflection also the reflection and having there is the searing sudden. Searing I explained, reflection I didn't explain to you. The reflection is simple thing. Okay, when I take this same object and I draw by the object here, and I want to be apply a triangle. Suppose triangles are there. I have to plot by that is the angle. Okay, we have to plot by the angle like 4 degrees are there now. We write from the angle one. This one. This are positive coordinates are there. Coordinates are there. I want to make the reflection object. Reflection object, I simply go from as the mirror image of the image. Mirror image of the image, you can give here. Same. The same image is there. I simply flip it. Flip it mean where you want to display the object now. Bottom of the screen only display. It's called about the reflection, mirror image. Same thing you want to flip from here. Okay, simply copy and paste. For the example, I'm saying. Okay, the compromise the flip. You can see now. Same thing will become here with having the angle wise. You see now this curve, this curve. It's all about the reflection. Only that they have to add in the coordinate value going to change. Coordinate value change here plus plus. They having the plus plus minus here and minus 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 plus will be there. It's confirmed as the continuous transformation I want to perform. Okay. Thank you, student. This is my class. Okay. We'll see it on that is the 2D transformations. Like. Okay. Thank you.